Okay, welcome back. Got a quick little review for you before we jump into some new stuff here, but the review comes as far as multiplying variables goes. I want to remind you, if I'm going to multiply x squared times x to the fifth, well, x squared is really just x times x, and that is being multiplied by x to the fifth, which is x times x 5 times. And then if you look at this and you ask yourself, okay, how many x's do I have now after I multiply these together? Well, I have 7 x's, x to the 7th. So the reminder is that when you multiply variables, you can add their exponents. I'll type that in up here in the box. Hopefully you're taking notes there, you should jot that down. When multiplying variables, I add exponents. Almost fit it in the box there. Okay? So when I multiply variables, I add their exponents. So when you look at example 2 over there, keep in mind that we multiply y's together and x's together. Now this y here is an understood first power. That won't be written, but you need to know that so that when you do multiply y to the fifth times y to the first, you know to add those together. But let's do these in alphabetical order. X squared times x to the third, that would be x to the fifth. That's multiplying this and this together. Remember, multiplying is a commutative property, so you can multiply in any order that you want. And then y to the first times y to the fifth would be a y to the sixth. I cannot multiply those two together because they're different variables. Okay? We can only multiply like bases, or you could think of it as common variables. Okay? So now let's talk about something a little new that maybe you haven't seen before. What if I'm going to multiply exponents that are fractions? Okay, so if I'm going to multiply exponents that are fractions, it's still the same idea. I'm still adding these exponents together because I have common bases. So this is going to be a to the. Now I'm going to do 1/2 plus 3/4. Quick little reminder as far as adding fractions. Anytime I add fractions, I want to have a common denominator. In this case, I look and I see, well, I probably want to use a common denominator of 4 here. So 3/4 is not going to change, but 1/2 needs to become 2/4. And I can do that. Basically, I just multiplied top and bottom by 2. And then when I have 2/4 plus 3/4, that is 5/4. So this is going to become a to the 5/4 power. Okay? And you can leave that as an improper fraction. We do not want to write that as a to the 1 1/4 power. Okay? If you want to do that adding of fractions in your calculator, that is allowed. You will have your calculator on the test, so you can keep that in mind. If I look at the next example, let me move this over here. If I look at the next example, I want to multiply the like bases together. So my first like base would be the m here with this m here. And then the other like base on this problem would be this n and this n. Now, although the first n there does not have an exponent, I know that exponent to be a first power. Okay, so let's look at the m's first. I'm just going to rewrite this just to put them next to each other. I have m to the 2/3 times m to the 4/3. And then I have n to the first times n to the 3/4. Okay, if I'm going to multiply the m's together, m to the 2/3 times m to the 4/3. Remember, when I multiply fractions, I'm really just multiplying straight across. Okay, I can reduce first if I want, but there's nothing to reduce here. I'm going to multiply straight across. 2 times 4 is 8. I'm sorry, time out. Let's go back. I'm getting my things mixed up here. I'm not multiplying these, I'm adding these. I know some of you are at the other end of the computer right now screaming, hey, I'm not going to add those, or I'm not going to multiply those, I'm going to add those. And if you were, then you're right. I need to add these. So 2/3 plus 4/3. Okay? Well, when I add fractions, I only add the numerators. I do not add the denominators, so that becomes 6/3. And 6/3, as you know, reduces to just 2. So m to the 2/3 plus m to the 4/3 is really m to the 6/3, which reduces to just m squared. 2/3 plus 4/3 equals 2 wholes. Okay? Now, if I want to add n to the 1, the first power, plus 3/4, well, let's get a common denominator. I know 1 to be the same thing as 4/4. And when I do 4/4 plus 3/4, that gives me 7/4. So this is going to be n to the 7/4. These cannot be combined because they are not common bases. All right. So, what if I have a power raised to a power? Well, remember what a squared is. Or a squared, when you take something to the 4th power, in this case a squared is being taken to the 4th power, that means a squared times itself 4 times. Anything to the 4th power is that thing times itself 4 times. So if I have all of these now being multiplied together, I know I can add their exponents, and this is really a to the 8th. So sort of the shortcut that we use here is we say, all right, when taking a power to a power, I multiply exponents. I'll take this and I'll kind of shift it up there. It's not going to fit quite in the box, but you get the point. Okay, so when I have a power raised to a power, a squared to the 4th, that's a power to a power, then I can multiply those exponents together. It's a bit of a shortcut. So in my next one here, this is an understood n to the 1st power. So each of these terms are being raised to the 3rd power. So I have m to the 3rd raised to the 3rd. If I multiply those, that gives me m to the 9th. And then I have n to the 1st raised to the 3rd. And if I multiply those, that gives me n to the 3rd. 1 times 3 is 3. And that is done. I cannot combine those because they're not common bases. Okay, well, let's attach that to a fraction piece. Okay, so if I have a power raised to a power, then I can multiply these together. So really what I want to do, this becomes x to the basically 1/4 times 2/3. Okay, and 1/4 times 2/3. Now here's where I was saying before. Whenever I'm multiplying fractions, I just multiply straight across, or I can reduce first. If I multiply straight across here, I'm going to get 2 over 12, which I'm then eventually going to have to reduce to 1/6. Now when you were back at this step here, 1/4 times 2/3, if you wanted to reduce the 2 and the 4 to a 1 and a 2, and you multiplied straight across, then you would get that 1/6. So either reduce first and then multiply, or multiply and then reduce. It's up to you. I would actually probably reduce first just because it's easier to multiply smaller numbers. Okay, last example here, and then we'll call it a day. I have y squared raised to the 4/3, so I'm going to multiply those. That's really like saying y to the 2 over 1 times 4 over 3. Okay, and then I also have z to the 1/3. That's really hard to see, sorry about that. Z to the 1/3 raised to the 4/3. So that's going to be the same thing as multiplying by 4/3. When I have a power raised to a power, I can multiply. So there's nothing to reduce here with the y. This becomes y to the 8/3 if I just multiply straight across. And then for the z, nothing to reduce there. If I multiply straight across, I get 4/9. That is simplified. Nothing left to do. Okay? Thank you so much. As my son hits some button and plays some little song for you, I'm going to take off.